Right, okay, so I'm going to talk about the Anthropocene and the memory of the Earth. So the memory of the Earth, how does the Earth remember? And this paper, the lines of thought that I'm going to present to you were prompted by preparations that I've been doing with Bruno Latour for our project that we're staging in Toulouse in France next month on the Anthropocene monument. And we're using the Anthropocene for as a stand-in term for whatever it is that we might think is happening to the Earth right now. And we're using the idea of a geological monument, a monument to a geological age, its aesthetics, its semiotics, its materiality, as a way to think through issues about the current predicament. But when I started thinking about this notion, this ridiculous notion of an Anthropocene monument, I started thinking about how we needed to situate it, not just within the history of human memory practices, the changing uses and meanings of memorialization in the late modern age, but also we needed to situate it within the deep time of the Earth that Antonio Nobre was talking about this morning. So therefore, within the Earth's own memory practices. So what could this possibly mean? How does the Earth have memory practices? So in the rest of this paper, I want to share with you my first thoughts about this. So what memory systems do we think the Earth might have evolved in its 4.5 billion year geostory? How does the Earth or Gaia remember and forget? And how might the Anthropocene insert itself into the memory of the Earth? Is it just another layer, another memory for the Earth, or does it actually change the Earth's power of remembering and forgetting? And can thinking about the memory of the Earth change the way that we think about this thing called the Anthropocene, what it is and what it means? So what kind of concept of memory do we need to think about the Earth in this way? So I'm just going to list 7 characteristics that I think the idea of memory would have to have for it to do this kind of work. So firstly, obviously, we need to think about memory in a way that can cross the divide between the semiotic and the material, between the living and the non-living. But we mustn't just use memory metaphorically. Let's try to think of human memory as a specific example of a wider phenomenon that we see in the Earth. And I don't think that necessarily has to imply that the Earth is some kind of unified being, a god, you know, which has a memory in that sense, as Bruno has pointed out. And secondly, I'm really pleased that we had Mauro Almeida's talk yesterday afternoon, because I want to claim that any general account of memory has to engage to some extent at least, or at least as a first position, with thermodynamics. And this is not to reduce memory to being a thermodynamic phenomenon. If anything, it's more like treating thermodynamic processes, these very strange processes where matter self-organizes, as a subclass of a larger category of phenomenon. But certainly thermodynamics allows us to draw an improbable line between, on the one hand, Claude Shannon's mathematical theory of information, to, on the other hand, the continental philosophy of people like Georges Bataille, Michel Serres, Gilbert Simondon, and Gilles Deleuze. And also I think thermodynamics is useful because memory, in some sense, is time, a particular kind of the internal time of things, so that we have to think about memory and how it relates to the arrow of time that Mauro talked about. But also, memory, I think, in any interesting sense, has to be understood as a phenomenon that occurs on the borderline between chaos on the one hand and order on the other. So the limit cases of memory, where memory sort of disappears into something else, is on the one hand is white noise, random motion, with no memory or correlation between one event and the next. And on the other side, black noise, effective silence, duration without event, a total memory where future states totally correspond to previous events. So memory is in the middle of these two extremes. So let's think about that. Okay, thirdly, I mean, this is my third of 7 points about memory. Memory is in some sense an auto-relation, a relation to the self. As Deleuze puts it, following Kant, memory is the real name of the effect on self by self. So memory is something topological. It's about the shape, in some sense, of the entity or assemblage that is said to have memory, how it is folded, made to affect itself through time. So memory is a relation of self to self. So the memory of the earth is, in some sense, the relation of the earth to itself. So fourthly, there are of course different kinds of memory, and we need to maybe tease it apart. You know, in the case of human beings, we talk about long-term memory and short-term memory, which I don't have anymore, for example. Or we think of episodic memory, which is the memory of something, an event that happened, the dinner we had last week, something that happened at a particular place or time. And something like these kinds of distinctions might be useful when we think about how the earth and the parts of the earth remember. So fifthly, if memory is time, it can also be converted to space and back. So think of the memory palace used by classical and Renaissance orators, where memories were placed in different places in an imaginary building. Or think of writing, or placing things at the bottom of the stairs to remind you to take them up stairs, as an act of delegation in Bronislaw's language, or of distributed memory. And we can call all of these mnemotechnics or hypomnesia, and follow Bernard Stiegler into seeing this as an exteriorization of memory in the things around us, the artifacts, you know, the chair to make me remember to sit up straight and things like this. So sixthly, memory also involves forgetting. So forgetting is not just a lack of memory, forgetting is an active process, a skill. Just as Elizabeth Povinelli was saying, you know, to die we have to be a living being, to forget we have to be a remembering being. And specific kinds of memory can require forgetting, selection, erasure, and this will be important when I talk about how the earth forgets in order to remember in different ways. And seventhly, and finally, if memory is about auto-affection, as Deleuze puts it, it has to be active and constitutive, affecting how something reacts to its environment. So we can think about memory as a part of the way an entity goes on in time, the specific way it endures through time. And here, forgetting can be just as important as remembering for the ability of an entity to act. So as well as hypomnesia, the placing of memory outside you, there's also hypermnesia, over-remembering. In order to act, the individual sometimes has to overcome the weight of history. So, as Nietzsche says, the human has to rediscover the animal power of forgetting to develop a memory of the future. So we'll have to ask also whether the earth is capable of creating and developing a memory of the future that makes it act in surprising ways. Okay, so thermodynamics and memory. So I don't know as much about Mauro as Mauro does about thermodynamics, but here goes. And I share some of Bruno's discomfort with the word system. Perhaps Haraway's non-linear couplings is better, but I'm going to use that language for now of systems and subsystems. I think it'll do. So, as I hinted before, memory in the sense that I'm using it emerges in systems, assemblages, couplings that are far from equilibrium, on that generative boundary between order and chaos that Isabel Stengers explored with Ilya Prigogine many years ago. So the arrow of time, which thermodynamics says, the second law that we've learned so much about this week, says points in one direction to equilibrium, to entropy and disorder, does funny things on that boundary. And many complex systems have a tendency to evolve not to a state of maximum entropy, but to a state of self-organized criticality. This is per Bach's term. So Bruno used, on Monday, used Lovelock's Daisy World to illustrate this. And instead, let's imagine we're going down to, which might be quite nice actually after being stuck in here all day, let's imagine we're going down to Copacabana Beach and we're going to play not Daisy World because there's no daisies on the beach, we're going to play Sand World. And let's see how the power to decrease entropy is not just the power of elites over the poor, but is also the power contained by very humble things like grains of sand. So let's stay above the high tide mark and fill up a bucket with nice dry sand. And if we pour the sand slowly out, a pile will start to form, and it will get steeper and steeper until it reaches a critical angle. And beyond that point, the sand pile will still get taller, but the angle won't change. The sand pile will start to organize itself so that any further addition of sand will cause cascades of avalanches to flow that maintain the pile at the critical angle. So using the language that Isabel developed with Prigogine, the sand particles in a flat pile in a state of equilibrium are hypnones, unaware of each other. They're like they're sleeping. But once the pile is built up to the critical angle, the whole pile becomes self-organizing, and a kind of resonance happens throughout the pile, as if the sand particles have woken up to each other. And you know when a system has woken up in this kind of way, when it's reached that self-organized criticality, when it starts to exhibit what's called pink noise. So white noise is fully random and it has no memory. It's the result of systems which have no memory of their previous states and just take a random walk through different states. In pink noise, the system has memory of past events, and it starts to organize itself in fractal ways, so that with a sand pile, the probability of any size of avalanche is inversely proportional to its size. So there's a kind of resonance going out. You can't predict when any avalanche will happen, but you can see that there's a kind of pattern to it as it maintains its criticality. Okay, so that's enough about that. So what's this got to do with memory? Well, the first thing, that self-organizing systems can remember what they are. A grain of sand falls onto our pile and it gets woken up and it exhibits a kind of anamnesis. It remembers suddenly it's a part of the pile and joins the dynamic, but it has to forget what it was before. Although, interestingly, Copacabana sand doesn't totally forget what it was, because if you look at it, it's really, really round. It's lovely and smooth because it's really old pieces of quartz that have been rolling around the earth for a long time, so it kind of remembers that it's old, and so the piles don't go very high. But a self-organizing system also has a kind of working memory, which is how it organizes itself over time, and it also can have other kinds of memory, but I'm going to jump ahead here. So how does this apply to the Earth? Well, the Earth, as we've heard already, has this huge applied energy gradient from the sun. And I know Peter Shendy is going to talk about Bataille later on this week, so I won't talk more about Bataille's way of talking about the sun and the Earth, but it's got this incredible gradient of energy, you know, from the heat of the sun and the coolness of the Earth, and the gradient between the equator and the poles. And the Earth has this, as it were, compulsion thermodynamically to evolve towards states that gives the maximum way of dealing with this excess energy. And this is that drives the gift economy of Gaia. But there are also phase changes. So metaphorically speaking, the Earth doesn't remain a pile of sand. It's not just a thermostat either. It has what Bruno calls a geostory. It's evolved in complexity, rather like an egg as it forms in the hen or in the body. Evolves in complexity through a progressive unfolding of singularities, a cascade of what are known as symmetry-breaking bifurcations. So rather like an egg, the Earth started as this undifferentiated mess, like a cloud really in space, but became progressively more anatomical or geometrical. It did this through various processes, particularly of folding itself within itself, creating the surface as it accreted the surface, so it's got an inside and an outside, and then melting, and so the core, the iron sinking to the bottom, so it's got a core and a mantle, and then starting to generate crust, continents, life, oceans. So we have shorelines, you know, creating all these folds and boundaries. So Gaia is really the thousandfold that Bruno talked about. And as it creates all these new extensive structures of the structure of the Earth, that creates new intensivities, new gradients, new differences in temperature, pressure, concentration, and creates all these new forms of self-organization. Okay, so let's talk about the memory of the Earth. How does the Earth remember? Now, we could talk a hell of a lot about ecological memory, social memory, and so on, of living things, but I want to focus really at the other end, because I haven't got much time, and I think that's more interesting for us and more unusual, perhaps. So I'm going to talk about air and rock, and then talk about interactions between the different memory systems of the Earth, because I think the interactions are really interesting as well. So let's talk about air memory first of all. So the atmosphere is self-organizing. It organizes itself into these distributive systems, like this cold front that Renzo was talking about coming over from Argentina. But the memory of the air is really, really tiny compared with that, with the memory of other parts of the Earth. That's why we have this thing called weather, which is so difficult to predict. So sometimes when you get an anticyclone or a cold front, a clear thermodynamic pathway has developed, and the atmosphere develops this working memory which keeps it going through time, keeps it in form, and you can predict weather 3 days maybe, up to 10 days if you're really lucky. But at other times, the atmosphere can have no memory at all. So why does the air forget? Why does it have such a bad memory? Is it just because it's old? It's partly just to do where it's gas. You know, don't expect too much of the air. It can't really form very complicated structures. It's gas, it's vapor, it's wonderful, it's fantastic, but it can't really preserve those structures very well. But it's also, interestingly, to do with the topography of the Earth below it, because other planets, like the gas giants, have these amazing clouds that can last, like the red spot on Jupiter, or the hexagonal cloud over the North Pole of Saturn, that can last for hundreds of years. But the Earth has these things called mountain ridges, and as the air passes over the mountains, it disturbs the memory of the air, and it makes it forget. And also the clouds in the air make the air forget as well. But then the air also can put its memory outside itself. I'll come back to that later. But I'll move on to rock memory now, because what about the rocks? And the rocks of the Earth have longer memories, of course, that's not surprising, but also more complex forms of memory. So first of all, of course, there are the traces of the past in the rocks, as interpreted by geologists, as Dipesh was talking about, the work of Jan Zalasiewicz and everything, anticipating the traces in the rocks of the Anthropocene in the future. And the Earth shares this with the other rocky bodies of space, like the Moon and Mars and so on. But the memory of the Earth is different, and actually it's not just the Earth has life, although life helps greatly, but the Earth is a strata machine. This is what Jan Zalasiewicz calls it. It has this amazing power to generate strata, different layers of the Earth, which record time in these complex ways, but through the combination of lateral tectonics, continental building up continents, and the water cycle. There are zones of erosion in the uplands pushed up by tectonic collisions, and zones of sedimentation down the coast. So the forgetting of erosion up in the hills contributes to the memory formation around the coastal zones, you know, through the great river deltas and so on, the building up of layers. But the memory of the Earth is not just the passing capture of traces, like a kind of writing pad, if you like. For a start, the minerals themselves have evolved through the time of the Earth. In the early stages, when the Earth was forming in the solar nebula, there were just a few minerals, a handful of different kind of forms of minerals. But over the time of the Earth, through the symmetry breakings of planetary accretion, tectonics, continents, life, the great oxygenation event in the atmosphere, this huge variety of minerals that we see today has evolved. So, you know, rocks evolved, not just life. And strata are more than a record of what has happened to the Earth. It's also a record of what the Earth how the Earth has organized itself and what it has been able to do. So rather like Dipesh said about the human body containing within itself its own history, that's why, you know, we get diabetes and so on. The rocks record the Earth's own internally generated story. So the internal topology of sedimentary rocks, so that if Copacabana Beach in future became a beautiful piece of sandstone with these great undulating lines in it, you know, this will record in millions and millions of infinitesimal landscapes all laid on top of each other in this sort of wonderful pattern. Okay, so I've talked about the memory of the air and its fragility and the different kind of memories of rocks. I could say much more about the different rock memory systems as well. But there's really interesting interactions of transduction, if you like, of translation and interaction between the memory systems. So first of all, the atmosphere's very short memory is improved by being in contact with the ocean and the land. So the air practices its own mnemotechnic, its own way of putting its memory outside itself, exchanging moisture and heat with the ocean and the land, and thereby reminding itself from one year to the next what the previous summer was like, whether it was hot, dry, cold, wet, and so on. And ice sheets give the atmosphere even longer memory. The ice sheets, in fact, are still recovering from the last ice age, and so their memory, it can help the atmosphere remember for thousands of years. And the interaction between rock and water is also really complex too. So as well as water having its own memory dynamics, which I don't have time to talk about here, water's properties are borrowed by rock memory. So first of all, the water plays a crucial role in keeping the machinery of tectonics going. So one of the reasons why Venus is a tectonically dead planet, it doesn't have any movement in its crust and magma, is because all the water evaporated, because water keeps it all moving. Also, of course, water is crucial in the creation of new strata through sedimentation. Water plays a crucial role in preserving strata by overlaying them with new strata, but also in destroying them by keeping lateral tectonics going, and so on. So water plays this really important role in memory and forgetting in rock memory. But also rock helps the water's memory, and let me give two examples. And the first is about the movement of water. So let's go back down to the beach. So note how, as each wave rushes up the shore and then drains back down again, it reorganizes the sand into forms which then affect the ability of the next wave to drain back. So the water can learn, remember what it did last time. But of course, this is really crude compared with what happens in river basins over hundreds of years, which self-organize themselves into wonderful fractal networks that drain in optimal ways. And there's been some lovely studies of the way river basins self-organize. And the second way that rocks help the water to remember is geochemical. So the rock-water system, the rock-water kind of interaction evolves over time, is evolved complexity over the age of the Earth. So once there was free water on the Earth, the relationship between water and rock becomes this complicated system of equilibrium and non-equilibrium, where the water can never be in total equilibrium with the rocks around it because of all the different kind of minerals and elements that are interacting with it and getting dissolved. So it starts to behave as this complex self-organizing structure which produces new forms of minerals but also new chemical types of water over the time of the Earth. So it creates this really quite complex self-organizing system with memory. Okay, so to summarize what I've said so far, I've said the Earth in its symmetry-breaking transitions, in creating a surface, a core, continents, atmosphere, life, oxygen, has developed these different interlinking subsystems, each with their different forms of memory. I've also said that the Earth, Gaia, has working memory, sustained dissipative systems of different time scales. It also has long-term memory in the subsystems, particularly which have evolved this massive complexity like rock strata, mineral species, biota, ecosystems, all of which bear the traces of their complex history. Each system of memory, I've also said, has also its own forms of forgetting, which are crucial to their operation, and also memory systems interact in complex ways, sometimes in ways that the memory of one system depends on increasing the amnesia of another system, of degrading it, if you like, and sometimes in forms of hypomnesis, in which the memory of one system is increased by placing memory inside other systems. Okay, so I don't know about you, I think that's all quite interesting. So we might also wonder about how these great phase shifts and symmetry breakings of the Earth might have left echoes or suppressed memories. Let's get a little bit psychoanalytic here, just bear with me for a while, indulge me. So here we're in the vicinity of the sort of thing that Nick Land calls Geo Trauma. So I don't know if you've heard of Land's theory of Geo Trauma. So this is the idea that he put into the mouth of a fictitious scientist, Baxter, The idea that all personal human trauma is a recapitulation of the traumas undergone by the Earth during its evolution, during these symmetry-breaking events. So during the Archean era, when the molten core of the Earth was buried underneath the crustal shell, Land puts it through his fictional Professor Baxter, this is the anorganic metal body trauma howl of the Earth, which echoes through the ages and sort of conditions our own experience. So let's think of a couple of geotrauma events, I suppose. One is the great geotrauma event that Bruno mentioned when the atmosphere started to accumulate free oxygen about 2.5 billion years ago, became toxic to the very living organisms that were producing it. So Lynn Margulis suggested that maybe it was this oxygenation event that led to the prokaryotes, these little organisms taking shelter inside other cells, which produced the nucleated eukaryotic cells out of which all plants and animals are assembled. I think we heard something about this. We saw an animation of of mitochondria and so on, didn't we? So whatever the advantages of nucleated cells, Land argues that the command control model of genomic read-only cells, where the nucleus controls the cell and therefore the organism as well. This kind of what he calls the locked up, suppressive, more or less obedient to Darwinian selection mechanics of all modern animal and vegetable life is in a way a result of this trauma of the great oxygenation event, which led to the prokaryotes having to escape into the cells of other beings. So in some way, maybe all of our the logic of animal and vegetable life has been shaped by this geotrauma. And what about also looking around? If you're standing on Copacabana Beach and you look around and you see the beautiful granite Bornhards, what are called, these lovely dome-shaped granite hills around Rio, like Sugarloaf Mountain or Corcovado mountain where Christ the Redeemer stands. Well, these were formed by erosion on these granitic intrusions, that making the steep sides and flat tops. But one of the reasons why these are so tall and steep and striking in Rio was to do with the crustal stresses produced by the splitting of South America from Africa about 120 million years ago. So the very landscape we see around Rio somehow recapitulates this great sort of geological trauma that produced this beautiful coastline, but actually sundered, the old continent of Pangaea. Okay, so in the last few minutes, I'm going to talk about there's some reflections on how this might relate to the Anthropocene. Okay. So so firstly, we could say maybe the Anthropocene is a scrambling of the memory systems of the Earth. Maybe this is what we are looking to see. Not just for observers, so there will be no clear signs in the future of the structure of the Earth, but also for the Earth itself, so that the Earth forgets what it knows, what it's learnt, what it's done over the millennia. So imagine the Anthropocene as a huge transient, this great wave that washes across a catchment area, and think about the sort of different forms of forgetting that such a transient, a wave, a tsunami could cause. So first of all, a wave like that could degrade memory. So it could cause a loss of rock memory by mixing up the strata, so thinking about what we're doing and mining and overturning strata, but also a loss of cultural memory and ecological memory. Think of what Leslie Green said about the fracking sacrifice zones, or what Mauro said about indigenous peoples pointing to the disorientation of animals as the main indicator of ecological entropy. So even the animals forget what they knew, how to move around in their ecosystems. So secondly, a transient, a tsunami or something like that, a shock to the system, can also activate new singularities, tipping systems into new basins of attraction, which completely wipe any memory of the previous metastable state and push the system to build new memories in its new basin of attraction. So imagine if the circulation of the oceans shifted to a new pattern, or invasive species, come in and move in to an area and bring their own memory with them. But finally, also, in terms of the scrambling of the memory systems, this shock to a system can also push a system away from criticality, so thus destroying its own mode of self-organization. So imagine if someone stands on the sand pile, you know, it no longer can self-organize itself. So a whole mode of memory could be wiped out if there were no humans, for example, to read the archive of geology, or if life died out. Okay, but maybe secondly, the Anthropocene also, of course, involves the laying down of new forms of memory, and this is the kind of meat and drink, if you like, of Jan Zalasiewicz's Anthropocene working group, which has to see even the forgetting of biodiversity loss or something like that as the laying down of a trace in the rock. So when Rio joins the geological archive, will it be submerged, sedimented and preserved, or will it be pounded to destruction? Of course, the great storm that you had in 2010 suggests it will probably be a bit of both. And then thirdly, we could also consider whether what we're struggling to name at the moment, Gaia, the Anthropocene, is in fact the Earth adding a new memory system or new ways of remembering. How could we name this new memory system? Is it the technosphere, as some people have suggested? Is it the capitalosphere? Maybe it's the metrosphere, to do with urbanization, the cybersphere, the Cthulhu sphere, maybe Haraway would have it. Probably some combination. But if there are new forms of memory emerging in the Earth, then typically, as we've seen, the new forms will depend on the old to continue, but also will depend on degrading the energy and information being used in the other memory systems. But we've also seen that memory systems can, in a sense, help each other, water and rock, rock and water. And we've seen how memory systems can also carry over deep buried memories from older times. So are the new Anthropocenic memory systems of the Earth wiping the memory from the old, like the mountains wipe the memory from the air, like a sort of the old erase head on a tape recorder? Or are they bringing to light, opening the archive of the Earth from its incarceration? So are the archives that record extinct and endangered species and lost ecosystems a form of mnemotechnics as the biosphere loses its internal capacity to remember what is being lost? But I think we must also remember what Derrida said about archives in Archive Fever. So in contrast to live or spontaneous memory, mneme or anamnesis, the archive, the kind of collection of memories, the prosthetic collection of memories, tries to protect memory from destruction. But of course, the hypomnesia of the archive contains within itself a vulnerability, which could achieve the very destruction of which the archive is trying to resist by containing memories together and repeating them and making them sort of dead memories. So the archive can work against itself. And we know, of course, that spontaneous living memory that is passed from moment to moment is vulnerable. We've seen that with the air, how quickly it can forget as it passes on or tries to pass on its oral history from molecule to molecule. Whether it is the strata of the rock or the archive in humans, whether we think of the archive of the strata of the rock or the archive that humans make to try to record Earth's memories, the archive's very form of resistance to forgetting makes it vulnerable to a more final forgetting, either the hiding, the closing of the archive and its concealment, or the destruction of the archive. And it's interesting that the closed archive of the solid body of the Earth is now being opened in the Anthropocene, but at the same time kind of ransacked. So to end, you'll be relieved, I'll end with a choice. It's not rock, paper, scissors, which one wins. It's something more like rock, water, air, life. Which kind of memory is strongest? Which will last the longest? Will the different forms of memory, as the Earth goes forward, undermine or reinforce each other? When we remember the Earth, remember for the Earth, do we remember as a storm, a vortex, as living memory, or as a mountain, a great archive? Which of these will enable the Earth to act in the way it needs to at this time? Thank you.